Today we are going to solve a paper of physics, which is Cambridge O Level 5054/22. It's a paper from October number 2022 and a theory paper. So let's get started with this. So question number one. Question number one states that a train travels along a straight horizontal track at time t equals to 0. The train passes through the station P at the constant speed without stopping. The driver applies the brakes at 70 seconds before reaching the station Q. The train decelerates. Figure 1.1 is the speed time graph of the train from t equals to 0 until it stops at station Q. So you guys have to see the graph why it says speed, and on the train this is time on x-axis. Using figure 1.1, determine the distance between P and Q. Okay, so now you must have learned this thing that this is a trapezium, so you just apply the formula over here, and that will be just area of trapezium equals to 1 over 2 sum of parallel sides. This is going to be 126, and this is going to be 20, 40, 60, and this is going to be around 77. Okay, so now what I'm going to do is I need to find out the parallel side, this one as well, and this is going to be around yes, it's going to be around say 56. So now I'll apply the formula 126 plus 56 times 77. So if you calculate this thing, so you'll get your answer is around 7,000 meters, which is around 7 kilometers as well. Moving to the question number 2, and it says that the mass of the train is 3.8 into 10 to the power 5 kg. Determine the deceleration of the train in the 70 seconds before it stops at the station. So for this you have to find the coordinates, and the coordinates will be around 56, 77 and 126, 0. So if you go over there and you find these coordinates, so you'll find the deceleration, and it's going to be like 0 minus 77 upon apply the gradient formula. So 126 minus 56 is going to be minus 1.1 meter per second square. So over here the word is deceleration, you simply have to write no negative sign because deceleration means negative acceleration. So calculate the resultant force on a train as it decelerates. So now over here what you are going to do is F equals to ma. So mass is what, 3 into 10 3.8, just a second, 3.8 times 10 to the power 5 times 1.1, and this would give you 4.2 into 10 to the power 5 newton. Okay, excuse me. Okay, now moving to the next question. Next question states that the foundation that supports building a long concrete cylinder that are pointed at one end, a pile driver is a machine that forces the pointed concrete cylinders into the ground. Figure 2.1 shows pile driver. So this is the pile driver putting those concretes in this. What is saying, a heavy block of 2.9 into 10 to the power 4 kg is lifted into the air and then dropped onto the top of the concrete cylinder. This forces the cylinder to the ground. Figure this is the shape. The block, calculate the density of the material. So we know this thing, the density is equals to mass over volume. So what is the mass is 2.9 into 10 to the power 4. So this is your mass, and for volume you have to use this. It's going to be 1.8 area times the thickness, so this will give you 8.1 into 10 to the power 3 kg per meter cube. So this is your density. Okay, moving to the next question, and it states that the pile driver lifts the block from the top of the concrete cylinder through a height of zero point 0.8 meters. The gravitational field strength is this. Calculate the gravitational potential energy. So we know that the formula for gravitational potential energy is mgh. So mass is already given, 2.9 into 10 to the power 4. Value of g is this, and height is zero point 0.8. So when you multiply these values, so you will end up at 2 to the power, or 2.3 times 10 to the power 5 joules. Okay, the block is then dropped from the rest onto the top of the concrete cylinder. Calculate the speed of the block just before hitting that. So basically what you are going to do is gain of kinetic energy is equals to loss in gravitational potential energy. So apply the formula, which is going to be 2.3 into 10 to the power 5. So now if you do this thing, you cross multiply and make v subject, so it's going to be 2 times 2.3 into 10 to the power 5 upon 2.9 into 10 to the power 4. You will end up at 4 meter per second. Okay, now there's another question, and it states that the figure 3.1 shows a man standing underneath a outdoor heater on a cold evening, and gas in the cylinder is at the base of the heater, is the fuel of the heater. When the heater is operating, the gas travels to the top of the heater where it burns. State the form of energy stored in the gas that is transferred by the heater. So this is basically simple as this, that is chemical energy, potential energy. This carries 1 mark. So okay, now a metal screen surrounding the burning gas is heated by the burning gas until it is red hot. The hot metal screen warms the man who is standing underneath it. Describe how thermal energy in the red hot metal screen is transferred to the man and how it warms. So basically, what is happening over here, the red hot metal, this carries 3 marks. Red hot metal is transferring its heat by the process of radiation to the person, and radiation is what, traveling downward. Radiation travels downward. Okay, so this is how it is going to be processed. Radiation travel down the towards the man, and the man is going to absorb that heat, and his internal energy is going to be increased. Then at the top of the heater is a metal hood that has a shiny lower surface. Explain why this makes the energy transfer for the metal screen more efficient. So we know that the shiny surface are a good reflector of heat. So we are going to write this point, shiny surface will reflect the heat downwards. And then we are going to do this, loss of heat is reduced because of this shiny surface, and more energy will reaches the man. The air temperature decreases and the man puts on a pullover, black pullover. Explain one way in which wearing the black pullover helps to keep the man warm. So we know that the black is a absorber good absorber. This is a 2 mark question, so we have to write two reasons. Trapped air, because air is a poor conductor, and then is what you can also use reduces convection, as air is a good insulator. Air is good insulator. So these are 3 points. You guys can write any two of these to justify your 2 points. A sound wave traveling in the air of or water contain compression and refraction. Describe an experiment to show that medium is required to transmit sound waves. You may draw a label diagram if you wish to. Okay, this is the activity that we might have studied. Like you guys might have studied in the in your Cambridge O level syllabus. Like you guys can have a bell jar apparatus in which you can see this thing. If the this is your bell jar, it's going to be like this, and inside this there is going to be a bell, and there's a vacuum. So if you switch on the bell, so if you switch on the bell, so you will hear the voice, and if you create a vacuum in it, suck all the air inside the bell. So obviously, what will happen? There will be no sound. So sound needs a medium to travel. So this is what you are going to be explaining over here. So it's going to be if the bell is ringing, so it means sound is produced. So this is the experiment that you need to write it down over here. So it's a quite pretty easy and simple experiment. I've already explained it to you. When a sound wave passes through air or water, the molecules of air or water moves. Describe the motion of molecules due to the sound wave. So obviously they vibrate first of all, and this is a sound wave. So they travel as longitudinal waves, or you can call it as vibration, parallel in terms of, sorry for my spelling mistake, in the direction of propagation. Sparallel. Okay. Describe what is meant by refraction. Okay. This is the area where the particles are far away. Area where the particles are far away. Moving to the next question, and it says that figure 4.1 shows a dolphin and the range of audible sound ranges of frequencies for the sound for the dolphin is 75 to 140,000 hertz in water. The speed of sound is this. Calculate the smallest wavelength of the sound in water that dolphin can hear. So we know the formula V is equals to F lambda, speed equals to frequency times wavelength. So we need the lambda thing, so we will make it subject. So it's going to be V over F. V will be 1500 divided by 140. You will take the maximum frequency at this. So this is going to be we can rewrite this thing like small, and this is going to be the largest value. So it's going to be, because we need the smallest wavelength, so it's going to be, your final answer will be this. Okay, moving to the next question, and it states that the power supply in a circuit is made of from several cells, each with the same electromotive force. The cells are connected in parallel. Now you have to define what is electromotive force. So you can write it down: work done per unit charge, or basically work done is your energy as well. Energy to do work, and energy transferred to electrical energy. This is also the definition: energy transferred to electrical energy. And these are the two definitions of the EMF. State one advantage of using several cells in parallel rather than the single cell as power supply. So it's going to be last longer. First of all, you guys can remember this thing, that is going to last longer. Then it's going to be the energy is available for a longer time. Energy will be Okay, so the it's gonna last longer. Energy will be available for longer time. It will still operate if one cell fails. So these are the advantages of having power supplies in parallel. The power supply is connected in series to a resistor of resistance 4000 ohms and a thermistor. There is a voltmeter in parallel with the resistor. This diagram is shown. The temperature of the thermistor increases. Explain what will happen to the reading of the voltmeter. So you guys must know this thing to that the thermistor, when the temperature increases in thermistor, the resistance is decreases. So larger amount of current will be passing through this thing. So obviously when the resistance is decreased, so huge amount of current will be passing through this circuit. So what I'm going to write it down, the resistance of thermistor decreases, current changes, obviously is going to be increased, and the reading at voltmeter is going to be reading also increase. Reading at voltmeter increases. Next question. The EMF of the power supply is 1.5 volts. Calculate the reading of the voltmeter when the resistance is 8000 ohms. So this is a potential divider question. So you are going to use that formula, that is going to be R1 over R2 plus R3 times V. So basically, if you see this thing, let me zoom out. So power supply is what you need to do is you have to simply resistance is 4000 plus 12,000. 4000 plus 8000 is 12,000 times the 1.5 volts. So it's going to be 0.5 volts. So the reading at the voltmeter, this one, is going to be 0.5 volts. Okay, now this is another question, and it states that the primary coil of a transformer is connected to a main supply. The voltage of AC main supply is 240 volts. Figure shows this. Explain why the voltage is produced in the secondary coil. So now we have to identify why the voltage is going to be uh, produced in the secondary coil. So it's due to magnetic field, or you can say this thing due to magnetic flux, and it can be due to change in magnetic field, change in magnetic field, and this magnetic field change is going to produce the voltage is going to be induced. Voltage is induced. Okay, now there are the 5600 turns on a primary coil of a transformer and the 350 turns on the secondary coil. Calculate the output voltage of the transformer. So you have to apply this formula, Vs over Vp equals to Ns over Np. So voltage in secondary divided by voltage in primary equals to number of turns in secondary divided by number of turns in primary. So just plug the values over here. So it's going to be 240 times 350 upon, so it's going to be 15 volts. So your final answer will be there. Okay, the next question is this. The output of the transformer is connected to a 90-watt filament lamp which operates at the normal brightness. Calculate the current. So we know the formula P is equals to VI, and we have to make the I subject. So P divided by V is here going to be 6 ampere. So the final answer will be 6 ampere for this question. This is section B, and copper is sometimes chosen as material to make pans for heating liquids. A copper pan contains water at room temperature. The top surface of the water in the pan cools as water evaporates. The convection current causes the rest of the water to cool. Explain how this convection is produced. So basically, how it's going to be produced is water molecules contract and come close to each other when their temperature is going to be reduced. So first point, I'm going to write it down, water molecules. Okay, so these are the reasons that how convection current is going to be produced. And the next question is, the copper pan is now placed on a hot plate that is switched on. Name the process by which the thermal energy passes through the base of the pan. So it's obvious that there will be a conduction between solids, and then copper remains solid when heated up to 1000 degrees Celsius. State one other reason why it is sensible to make a pan out of copper. So again, it's a good conductor, and that's why you use it as a pans and in utensils. The water in the pan is heated 70 degrees Celsius until it starts to boil at 100 degrees Celsius. The specific heat capacity of the water is this, and the pan contains 750 grams of water. Calculate the energy needed to increase the temperature of water from 17 degrees to this. So the formula is Q is equals to mc delta theta, and this is going to be, if I need to find out the energy, so mass is going to be 750 divided by 1000, converting it into kilograms. Specific heat capacity of water, and this is going to be the change in temperature is this, so you will end up with 261450, which is equivalent to 2.6 into 10 to the power 5 joules. State two ways in which the boiling differs from the evaporation. So again, in the case of boiling, it is on the specific temperature, whereas specific temperature for boiling and any temperature for at any temperature for evaporation. So basically, what happens is that boiling happens at a specific temperature, whereas the evaporation happens at any temperature. So again, this is throughout process. The bubbles are basically heated. So in case of boiling, it's basically throughout process, the whole bubbles and whole liquid is moving. The particles of the liquids are moving. Whereas in the case of evaporation, it happens only on the top of the surface. Okay, so next question is this: at 100 degrees Celsius, the temperature of the water stop increasing, even though energy is still being transferred. Explain in terms of the molecules why thermal energy is needed to change the state of the water from liquid to gas. So it's basically the energy is used to break the bonds, the intermolecular forces, and at this point, the heat does not increase the kinetic energy, and the potential energy of the molecule is increased. Okay, so the next question is, the specific heat latent heat of vaporization is this. So you have this value, and then thermal energy is transferred by boiling the water at the rate of 1300 joules per second. Calculate the mass of water that boils away in 10 minutes immediately after the water reaches at 100 degrees. So we know that the formula for energy is equals to power times time. So you multiply 1300 into 10 multiplied by 60, and you will end up with this value. And then you will apply the formula for latent heat of vaporization. So from that, you make m subject and find out the value of the mass.